Okay. Please, somebody enthrall me with your acumen. Does that point lie on the circle, yes or no? Yes. So tell me how you're certain. I just don't want to know, hey, it looks like it's on the circle. I want to know how you're absolutely 100% positive. And I don't want to call on Izzy again. I don't want to call on Jake again either. Haven't you already answered a question, though? Is it your turn? All right. I'll call on Gabrielle.
You can just plug it into the equation, and if it equals 1, and it is.
Very good. You can just plug it into the equation of the unit circle. The reason why we do these problems is you do have to verify that a point is on a unit circle. So we can go ahead and just, for part A, just say, okay, well, if this is on the unit circle, we know that x squared plus y squared equal to 1 is the equation of the unit circle. So we can take 4/5, square it, sum it with 3/5 squared, and it should equal 1. So 4/5 squared is 4 squared over 5 squared. So that's going to be 16 over 25. Are we all in agreement? All right. And then 3/5 squared is 3 squared over 5 squared, which is, I'm hearing crickets, 9 over 25. So sure enough, that's going to be 16 25ths, and another 9 25ths will give you 25 25ths, which is also equal to 1. So good, I'm done there. Okay? Now, here comes the new part. And this is sort of a little warm-up to tonight's flip. One of the many uses of the unit circle is to quickly evaluate sines and cosines. When you get to your pre-calc and your calc classes, it's going to be like math facts, like we've been talking about. Somebody's going to say to you, what's the sine of 30 degrees? And you don't have time in the middle of a huge calc problem or pre-calc problem to be kind of figuring out what the exact value of 30 degrees is, okay? So this is going to say, what we're going to do is we're going to figure out how to find the sine, cosine, and tangent of that point, okay? So that point, let's go ahead and sketch it. It's 4/5, which is 8/10. So that's going to be the x-coordinate there, and then the y-coordinate is going to be 6/10. So there's my point right there. Okay? So it wants me to find the sine, cosine, and tangent of the angle whose terminal side passes through the point. You must draw it. From this point forward, until I say stop, every time you're asked to evaluate sine, cosine, or any other trig function, you have to draw the rotation diagram. Okay? When we stop, you'll be able to visualize it. Now, I'm going to go ahead and draw my initial side to the angle, which is always the positive x-axis. I'm going to open up my angle to about here. And there's the angle that's passing through the point. I don't know what the degree is. Okay, sometimes you do, sometimes you don't. But I know what the side lengths are, don't I? So I can drop a perpendicular. Now I've got a little triangle, don't I? You like my little triangle, Marcella? You see my little triangle? All right? It's a triangle, right? So what is this side length right here, since we're talking, Marcella? What's that side length? How long is that? What? Nope. Well, it would be 1 if it went all the way to the circle. I'm sorry, what? 4/5, right. But that's a really common mistake. Because what happens is kids see the positive x and they think automatically because the cosine of that angle there or that length is 1 on the unit circle, they think that this side of the triangle is 1. So I'm glad you said that. But there's a little piece here missing, right? So this side length of the triangle is 0.8 or 4/5. So let's go ahead and label that. And what do you guys think about this sine length here? 3/5, real good. So that's going to be 3/5. And we know what our hypotenuse is, right? So now can I find the sine, cosine, and tangent of that angle? Yeah, because remember, the sine, cosine, and tangent are just ratios of sides. Okay? They're going to be the same no matter how big the triangle is if the angle is the same. But if you don't have an angle and you have the sides, you can find it. And if you have the angle and you have one side, you can find it. And you can find it in different ways. Here they give you all three sides in the context of the problem, so we can go ahead and find the sine, cosine, and tangent. So now the sine is going to be the opposite over the hypotenuse. The cosine is going to be the adjacent over the hypotenuse. But here's one of the advantages of the unit circle. What's the length of my hypotenuse? Did you say 4?
I said
1,
one.
right, okay. It's 1. So I'm dividing the opposite side by the hypotenuse length, but I'm dividing by 1. So what's going to happen? You're going to get the same number. So do I really even need to divide by the hypotenuse? No. So here's the connection you will make, which is that the y-coordinate is also the sine value. Because you're dividing by 1, which means you don't have to divide. So really, the sine value, the sine of your angle is going to be equal to the opposite side, which is 3/5, over the hypotenuse. So that's the opposite. This is the hypotenuse. And because the hypotenuse is 1, it's really just the opposite side. And the opposite side is the y-coordinate. Does that make sense? Think about it for a second. What do you think, Rhea? We good? Harrison, what are you thinking about the cosine, man? Yeah. 4/5? Do we agree with Harrison, or should we shun him? No, he's good, right? How did you get the 4/5?
The same thing you're doing with 4/5 divided by 1, and anything divided by 1 is itself.
Right, because the cosine is the adjacent divided by the hypotenuse. So can't we say that the cosine is also equal to the x-coordinate? Or the adjacent side? Now the tangent is always the opposite over the adjacent. But didn't we say the opposite was y and the adjacent was x? Are we thinking that's okay? So can't I just take the y value and divide it by the x value to get the tangent? If you think about it, the tangent we've always defined as the opposite over the adjacent. Well, our opposite side is 3/5, and our adjacent side is 4/5. But we just said up here that 3/5 was the sine and 4/5 was the cosine. Now, don't forget, kids, when you're dividing fractions, 3/5 divided by 4/5 is equivalent to 3/5 multiplied by the reciprocal. So the 5s will divide to 1. So this is 3/4. A way you can do it nice and easily is, watch here, draw your eyes here. When you're dividing with the same denominator, this is going to be really helpful in the trig unit. All you can do is, because of that, you can just divide out the 5s right there. And you're left with 3/4. How are we feeling? Are we okay? All right. So there was a lot of substance to what we just did. We made a bunch of connections that I don't expect you to be able to do right away. Because if you think about it, we're working here with two representations. We're working with trig values, and we're also working with circles. And we're working with x's and y coordinates, and we're turning them into sines and cosines. There's a lot of stuff going on here. You're going to watch the flip tonight to kind of consolidate it, see it another time. Watch it carefully, take your time with it. And we're going to spend out some more time doing this as well. But the connection you want to make is that this side of the triangle divided by 1 is the adjacent over the hypotenuse. But this side is already the x-coordinate, and we don't need to bother worried about dividing by 1. That's why it's the unit circle. That's why it's so helpful. So that way, as you're doing your trig, you can say, oh, that's just that adjacent side. I don't have to bother dividing. Does that make sense? And the opposite side is our y-coordinate, and the opposite over the hypotenuse, again, 1, is the sine. So the y is equivalent to the sine. So that's why x and y is cosine and sine. Make sense? So that's the connection you need to sort of make. And don't worry if now you're looking at it like, oh my God, we're going to practice, practice, practice. But if you don't practice, you're going to be trying to tread water, okay? So make sure you don't slacken this unit, especially in the unit circle. Like I said, the unit circle are your math facts for trig. So important. If it's scary, it should be. All right? All right, any other questions? All right.